Are these functions linear or exponential? In our last class, we talked about the form y equals ab to the x. And we talked about how a was the initial amount and b was the rate of increase or decrease. When we want to check to see if a set of data is either linear or exponential, we're checking for one of two things to be present. Either a constant rate of change, so that's like a slope. The way we find that constant rate of change is to calculate what's called a constant difference. Whenever we have a constant difference, it tells us that we're going to have a linear relationship. So here's what we mean. We look at our y values, and I'm going to start at the end and work my way back forwards. If I take 27, and from that I subtract 9, so I'm calculating, looking for a constant difference. I'm going to say negative 27 minus negative 9, so that's really plus 9, and that's going to give me a negative 18. Then I'm going to check the next pair. So I'm erasing the negative 27. I'm going to do negative 9 minus negative 3. So it's negative 9 plus 3, which is negative 6. And right away I go, wait, those are not equal. I can conclude that since there's not a constant difference, I don't even need to keep checking. I can just say this is definitely not linear, and I can try something else. So the something else would be to look for what's called a constant ratio. A constant ratio is what gives us an exponential relationship. So we start out the same way. Remember before we started with the negative 27 and the negative 9? Well, when I want to calculate a constant ratio, I'm going to take the negative 27 and I'm going to make a ratio or a fraction with the negative 9. So I say negative 27 divided by negative 9, and I say, okay, that equals 3. Well, I don't know if this is constant or not until I check the next pair. So I drop the negative 27, I take the negative 3, and I say, okay, negative 9 divided by negative 3 is, hey, that's the same as before. It looks like this is going to be a constant ratio. So I'm going to check the last pair as well. So I'm going to drop the negative 9, I'm going to take the negative 1, I'm going to say negative 3 divided by negative 1 equals 3. And lo and behold, all three of these things are in fact the same value. So I can conclude that this table shows an exponential relationship because it has a constant ratio. That means that there's a y equals ab to the x relationship that would work for this particular model. Let's try this again with a second set of data. So first we're going to check for a constant difference, which means we're going to start at the end and subtract pairs. So we're going to say 5 minus 3, which is 2, and then 3 minus 1, which is 2, and then 1 minus negative 1, so 1 plus 1, which is 2, and we're like, hey, that worked out. We have a constant difference. I don't need to check a constant ratio because I already found something that works. So I can say that this relationship is linear because when a set of data has a constant difference, that's the evidence that it's a linear relationship.